There is a continent on Earth bigger than India. You have never seen it because you're standing on the only 6% of it that isn't underwater. Every map you have ever looked at left the rest of it out entirely. Every day, an inter-island ferry crosses the Cook Strait, carrying commuters and freight trucks between New Zealand's North and South Islands. Passengers watch steep cliffs slide past on either side and assume they're crossing empty water between two islands. They're not. Those cliffs are the exposed peaks of a mountain range, one edge of a landmass that runs to 4.9 million square kilometers, about the size of India, with 94% of it sitting under the Pacific. In places, more than 2 kilometers of open ocean sits directly on top of solid continental rock. Anyone who has ever landed at Auckland or Wellington has touched down on the summit of it. Drain the ocean away, and that ferry route becomes a valley running between two mountain ranges on a continent stretching for thousands of kilometers in every direction. New Zealand was never really two islands beside a continent. It's the 6% of one continent that happened to stay dry. Zoom out, and the puzzle only gets bigger. This isn't just the ground under one ferry crossing, it's a single body of continental crust larger than Greenland, once making up roughly 5% of the ancient supercontinent Gondwana. It sits directly in the shipping lanes of the South Pacific, crossed by satellites every day, and mapped, in fragments, by oceanographers for decades before anyone called it a continent. Ships had the depth soundings. Geologists had dredged the rock samples off its ridges: granite, schist, sandstone, the same stone that makes up every other continent on Earth. None of that was secret. That gap sat unexplained for the better part of a century. And still, for most of the 20th century, world maps stopped cleanly at the coastline of New Zealand, as if the ocean itself marked the true edge of the planet. By the time geologists finally added it up, humanity had mapped more of Mars than of its own ocean floor. An entire scientific field spends its existence mapping the Earth. Explaining how an entire scientific discipline missed something this size is the actual story here. You probably think this continent was discovered in 2017. It wasn't, not in the way that word usually works. Every ridge, every dredged rock sample, every depth sounding behind Zealandia's case had already been sitting in scientific archives for decades. The name is older than the announcement by more than 2 decades. Geophysicist Bruce Luyendyk coined Zealandia in 1995 as a label for a cluster of undersea plateaus nobody had yet unified into one thing. What happened in February 2017 wasn't a discovery. It was a verdict. A team led by geologist Nick Mortimer at GNS Science took Luyendyk's label and asked a harder question. Does this actually meet the rules we use for any other continent on Earth? For 22 years, nobody had checked. Take one piece of the evidence: a fist-sized rock, dredged from a ridge 2,000 kilometers east of New Zealand, hauled up from a mile of water by scientists on a research ship. It isn't basalt, the flat, dark rock that makes up ordinary ocean floor. It's granite, coarse, crystalline, the same continental rock under Paris or Nairobi. Multiply that sample by thousands, gathered across an area larger than India, and you get a pattern geologists already had rules for. A landmass counts as a true continent if it clears 4 tests. It stands higher than the ocean floor around it. It's built from a distinctive mix of igneous, metamorphic, and sedimentary rock. Its crust runs thicker and slower than the crust nearby, and it covers a large, clearly bounded area rather than scattered fragments. Zealandia's crust runs 10 to 30 kilometers thick, over 40 under the South Island, against roughly 7 kilometers for the ocean basin around it. Its plateau stands roughly 3,000 meters above the surrounding ocean crust. And at 4.9 million square kilometers, it clears the size bar for a continent several times over. What it lacks is dry land. And dry land was never one of the 4 rules. A continent, by the only definition geologists actually use, is a question about the rock beneath your feet, not whether your feet are wet. Not everyone in the field is at ease with that. Geologist Christopher Scotese has compared Zealandia's case to Pluto's, a body that satisfies most of a definition without quite settling where a category's edge should sit. It's a fair challenge. Categories drawn by humans always have edge cases. But size isn't where Zealandia is vulnerable. At nearly 5 times the minimum continent area, the argument against it was never about the rock. It's about how much water above that rock still counts as the same planet. But if crustal thinning explains everything, a problem remains. The stretching that thinned Zealandia's crust happened as Gondwana broke apart roughly 85 million years ago. And simple thinning should have settled into a steady, gradual sinking soon after. It didn't. Drill cores pulled from the seafloor decades later show something stranger. Sections of northern Zealandia rising a kilometer or two, while neighboring sections dropped by roughly the same amount, tens of millions of years after the breakup was supposed to be finished. Something disturbed this continent a second time, and it wasn't the same event that started the sinking. The answer came from IODP Expedition 371, a 2017 drilling mission that pulled cores from beneath the seafloor and read them like tree rings. Zealandia's shape wasn't fixed by one clean break from Gondwana. It was finished by a second, unrelated event. Somewhere between 50 and 35 million years ago, the Pacific Plate began forcing itself beneath Zealandia's eastern edge, initiating subduction. As the angle of that plate steepened, it pulled the base of the continent down with it. That same subduction zone is still active today, part of the same tectonic reorganization that researchers now link to the birth of the Ring of Fire, the arc of volcanoes and earthquakes circling the Pacific. Zealandia didn't just sink once, at birth. It was pulled under a second time by the same process still building mountains and shaking cities across an entire ocean basin today. So how does an entire continent slip past science for more than a century? Not through concealment, through assumption. For as long as geologists have used the word continent, standing above water was treated as part of the definition, even though it was never actually one of the 4 tests applied to everything else on the planet. Nobody ran this landmass through those tests because nobody thought a submerged one qualified to be tested in the first place. That changed only once satellite gravity data and seafloor dredging built a detailed enough picture of the crust beneath the waves. A 2016 survey, EchoSat-2, dredged fresh rock samples from ridges nobody had sampled before, filling in the last gaps in a case that had been quietly building for more than 20 years. Only then could anyone apply the same 4 rules used for Australia or Antarctica and get a clear answer. What came back was unambiguous. This is the 8th continent on Earth, also the smallest and the most submerged one on the list. The rock itself had been a continent since it broke free of Gondwana roughly 85 million years ago and thinned until it sank. What changed in 2017 wasn't the rock. It was finally being willing to check. Zoom out from New Zealand entirely, and Zealandia changes the bigger picture too. It's now a working example of how continents actually pull apart, proof that a supercontinent doesn't always tear cleanly along one line, but can stretch and thin unevenly across an area this size. It also means the same subduction zone that spent tens of millions of years dragging this continent's crust downward is still active today, the same tectonic boundary responsible for New Zealand's earthquakes and for the volcanoes of its Taupo volcanic zone, still erupting on the surface right now. And underneath all of it sits the planar point. The map of this planet was never actually finished. It's still being redrawn. Zealandia's story isn't really about one hidden continent. It's about how much of this planet is still filed under ocean, simply because nobody has gone back and checked. Most of Earth's seafloor still hasn't been mapped to the standard that finally proved Zealandia was solid ground. Somewhere down there, something else might be waiting on the same 22-year gap between being real and being recognized.